So what we're going to do is we're going to find the lower quartile, the median and the upper quartile. One of the things that we have to bear in mind though is that all the data is being already laid out for us in ascending order. Usually it's not. You have to put it in ascending order first. So we've got 7 bits of data. To find the median, we do n plus 1 divided by 2. 7 plus 1 divided by 2 is 4. So the 4th bit of data is Q2. Now to find the lower quartile, what we have to do, we cover up the median. How many bits of data to the left do we have? We've got 3. We do 3 plus 1 divided by 2. 3 plus 1 is 4, divided by 2 is 2. So this bit of data here is Q1. That's the lower quartile. Now I look, everything's symmetrical. 1, 2, Q1, 1, 2. Back on ourselves. That there is Q3. Hey, if somebody said to me, what is the interquartile range? What is the interquartile range? I do Q3 minus Q1. That is the interquartile range. Okay? To find the interquartile range. Next thing, I'm going to have a go at this question here. I've got now 1, 2, 3, 4, 5, 6, 7, 8 bits of data. I'm going to find the median piece of data. So, 8 plus 1 divided by 2 is 4.5. 1, 2, 3, 4. That there is Q2, which if I don't know what the middle number is between those 2 bits of data, I add them together and divide by 2. So Q2 in this case will be 22.5. Okay, now I'm going to find Q1. So I cover this up. How many bits of data to the left do I have? I've got 4 bits of data. 4 plus 1 is 5, divided by 2 is 2.5. So Q1 here, Q1 is going to be 13. Q1 is 13. And look, everything is symmetrical. 1, 2, lower quartile. 1, 2, upper quartile. So here, Q3 is going to be 28.5. Okay, again, the difference between these two will be the interquartile range. The next question, which causes a few people some problems, is this question here. Find the lower quartile of 50 pieces of data. So what I try and imagine a number line. Okay, so I'm going to find the median piece of data. So I do the number of pieces of data plus 1 divided by 2. So what's 51 divided by 2? 25.5. So I'm going to look for the number which is between the 25th bit of data and the 26th bit of data. Now I'm going to find the lower quartile. So I cover this up. How many pieces of data to the left do I have? I've got 25. I do 25 plus 1 divided by 2. 25 plus 1 is 26, divided by 2 is 13. So the 13th piece of data, whatever it is going to be the lower quartile. Remember, the lower quartile is not the number 13, it's the 13th piece of data. Now what we're going to do is we're going to find the lower quartile of 29 pieces of data. So I imagine I've got a number line. I've got my first piece of data and my 29th piece of data. To find the median, 29 plus 1 divided by 2 is 15. Is my 15th piece of data. Now what I do, I'm going to find my lower quartile. So I do 15 plus 1. So I cover this up. Okay, so I cover this up. How many pieces of data to the left do I have? I've got 14 pieces of data. I add 1 and divide by 2. 14 plus 1 is 15, divided by 2 is 7.5. So the 7.5th piece of data is the lower quartile. So I'm looking, what is the 7th, what is the 8th, and I'm looking for the number in between. Thank you.